Alright, so this is a quick walkthrough of problem 5-21 out of the 12th edition Statics by Hibbeler. And this one's not too bad. We've just got a frame here, and it's supported by a cable from point B on the frame to a support C. And the orientation of that cable is given in terms of a 3-4-5 triangle. There's a applied force, an applied moment, and it's pinned at support A. And what we're asked to find is the tension in this cable BC, along with the reaction components at point A. So if we go ahead and draw a free body diagram for the frame, we first off have that 60 kilonewton force that's completely vertical. We have a clockwise moment of magnitude 30 kilonewton meters. Then at point A we have the reaction components AX and AY. And then at point B we have that tension force acting on the frame, and its direction is given also in terms of that 3-4-5 triangle. So the way I approached this problem was to first sum moments about point A, and if we do that, we don't have to involve the unknown reaction components AX and AY, since their lines of action intersect through point A. And so if we sum moments about A, we're able to outrightly just solve for the tension in this cable. So if we do that in terms of its components, first off, if we look at the its horizontal component, that's given by 3/5 times the tension magnitude times its moment arm, which is 3 meters. And that's going to create a counterclockwise moment about A, which I'm considering to be positive. If we look at its vertical component, that's given by 4/5 times the tension magnitude times its moment arm, which is 1 meter. And then looking at the 60 kilonewton force, that's going to create a clockwise moment about point A, which is going to be negative, and its moment arm is 1 meter. And finally, if we look at that applied moment of 30 kilonewton meters, that's a clockwise moment, and that also will have a negative sign associated with it. And since the frame is in equilibrium, we know that the summation of these moments must be equal to 0. So from here, we can go ahead and do a bit of simplifying, which gets us to this equation, and then that allows us to solve for the magnitude of that tension, which comes out to be 34.62 kilonewtons. And then from here, we can go ahead and solve for the reaction components AX and AY by just summing forces in the X and Y directions. So first off, if we go ahead and sum forces in the X direction, we get AX minus the horizontal component of this tension force, which is 3/5 times that magnitude that we just found. And so solving for A sub X, we get 20.77 kilonewtons to the right. And similarly, looking at summing the forces in the Y direction, we get that vertical component of that reaction at A minus this vertical component of that tension force, which is 4/5 times that tension magnitude. And then we've also got that 60 kilonewton force in the negative Y direction. And then we know that all those forces are going to be equal to 0, the summation of those forces. And so from there, we get A sub Y is equal to 87.69 kilonewtons in the positive vertical direction. And that's it for that problem. I hope you found it helpful, and thanks for watching.